The core of Web3 is built on the blockchain, but the blockchain can't store most of the information on the web. In fact, storing anything beyond basic transaction information on the blockchain is both slow and prohibitively expensive. To address this problem, Web3 needs to decentralize storage and connect that storage to the blockchain. Now, we already have a system that works here, peer-to-peer file sharing. If you were around in the 1990s and early 2000s, you may remember peer-to-peer technology being used to share music and video files, and this technology eventually evolved into BitTorrent, which is decentralized storage in all but name. I share a file on a network, someone else downloads that file and also shares it, then other people download and share the file, and soon the file persists in the decentralized network even if I turn my computer off. Decentralized web storage is a further evolution of this idea, and IPFS, the Interplanetary File System, is one of the most built out and operational versions of this idea. Here's how IPFS works. When a file is stored in IPFS, it's packaged in IPFS objects, each containing 256 kilobytes of data. If the stored file is bigger than 256K, which most files are, several objects are created, including an index object explaining how to put all these objects back together to recreate the file. Each object is given an encrypted hash describing the file, which serves both as the address for the object and as proof the object has not been tampered or altered with. These objects are placed on the network and duplicated by any IPFS node, so any computer or server running IPFS that accepts new objects. This is the decentralized part. The objects are distributed on the decentralized network. To retrieve a file from IPFS, you send a request with the hash address to the index object to the network, and the matching IPFS objects are returned to you from whichever nodes are closest to you. But this is a bit of a problem. When a file is changed, the file hash changes with it. So that means if a file is updated, the address to that file changes as well. This doesn't work all that well for things that can update, like applications or websites. To solve this problem, you can set up a mutable pointer, a literal link to something that can be changed over time, so whenever a new version of a file is added to the network and a new set of file objects are created with new hashes, the pointer redirects to point at the new version while leaving the old versions on the network as well. This means even though you update a file, the original file will remain on the network and be retrievable, which gives us historical permanence. So how does the blockchain fit into all this? By adding domain names on the blockchain through services like ENS, the Ethereum Name System. Blockchain domains are NFTs that point to pointers or addresses. So if you set up a file on IPFS, you can map the address of that file to your ENS domain NFT. This also means anytime you need to change what your domain points at, you need to update it on the blockchain. This method of file storage and retrieval is fundamentally different from how the web currently operates. On the traditional web, the web we're working on right now, you request files from a specific address, a domain name mapped on the global DNS, the domain name system, to an IP address. That's what HTTP, the Hypertext Transfer Protocol, does. Points at a physical location on the web from which we pull files. With ENS and IPFS, you request files by querying the blockchain for the address the ENS NFT points to. That request is sent to IPFS, and the network returns the matching IPFS objects from wherever they are stored, and finally your browser reassembles them into the files you requested. This process is a complete rewrite of how the web operates based on a whole new set of protocols and protocol interfaces for both blockchain-based domain name services and for decentralized file retrieval. As I record this, only a couple of browsers, namely Brave and Opera, support ENS and IPFS out of the box, though you can also get extensions for many other browsers to add support. And there are now Web3 browsers coming online as well.